Good afternoon, guys. This is Mr Coello, and welcome to another episode of SU Studies with You. Today, we'll go over the topic of greatest common factor and LCM, least common multiple, guys. What is GCF compared to LCM? Let's analyze and let's look at some examples so you guys get familiarized with those terms. And it will be very important for you guys to understand when you're dealing with fractions. All right, guys, so GCF stands for greatest and LCM stands for least. Sometimes the G and the L gets confused with students because they think greatest and they're looking for a big number where it's actually a small number that they had in common. And the same thing occurs with the LCM. We're looking for big answer and the students see, oh, the L stands for least and we want to look for a small number. It's not really the case, guys. So here, let's put some numbers in perspective. Let's assume we're trying to analyze 4, 12, and 8. What would be the greatest common factor and least common multiple of those numbers? So here, all of them are even numbers, so that's kind of neat. Worst case, we could divide by 2. I don't know if you saw the video on divisibility rules, but if you haven't, please see it, guys. It's going to help you get better understanding of this concept. 4, 12, and 8 are all factors of 4. 4 goes into 4 once. 4 goes into 12 3 times. And 4 goes into 8 twice. Keep on asking yourself, does 1, 3, and 2 have anything else in common? If they do, keep on dividing. If they don't, you pretty much end it. So this number on the right side, guess what? It's your GCF. You already have an answer. 4 was the greatest common factor between 4, 12, and 8. But if we multiply 1 times 3 times 2 times 4, that result will provide the least common multiple, which is 1 times 3, 3. 3 times 2 is 6. 6 times 4 would be, in this case, 24. Therefore, 24 would give us the least common multiple of those numbers, and 4 gave us the greatest common factor between those numbers. Let's put other numbers in perspective so you guys could see different examples and put it in practice, guys. So here, let's look for example. Let's change them for 9, 12, and 15. So now we're trying to compare 9, 12, and 15 to as well find the GCF and as well as find the LCM. So now here, what does 9, 12, and 15 have in common? All of them are factors of 3. 3 goes into 9, 3 goes into 12, 3 goes into 15. So we divide by that common factor. 3 goes into 9 3 times, 3 goes into 12 4 times, 3 goes into 15 5 times. Again, this number on the right side, it's providing our greatest common factor. If we were to multiply 3 times 4 times 5 times 3, that will give us the least common multiple. 3 times 4 would be 12, 5 times 3 would be 15, or you could do it in order. 12 times 5 is 60, and then 60 times 3 would be 180. You don't need a calculator, guys. You just need to get more practice to be able to multiply your numbers. All right, so now I hope that helps you a little bit see the difference between greatest common factor versus least common multiple. Why do we want to use this? Let's assume you have a fraction and we're trying to reduce them. Let's put, for example, 12 over 18. Here on 12 over 18, we're trying to reduce that fraction. You cannot leave your answer like that. 12 and 18 have to have a greatest common factor. You're like, they're even numbers. Cool, divide by 2. Maybe they're factors of 6. Maybe they're factors of 4. You want to try to look out what is the highest number. If we could see that they're divisible by 6, you try to divide and reduce by that common factor. 6 goes into 12 twice. 6 goes into 18 3 times. So our answer will be simplified to 2/3. And that worked out because we took away the GCF out of those numbers. Awesome. Another example where this comes in handy is when we're trying to multiply. Let's assume we have 12 over 28 and we're trying to multiply by 14 out of, 36. So again, we try to see what is a common factor between all of those numbers. 12 and 36, they're divisible by 2, by 3, by 4, by 6, even 12, guys. If you see the greatest common factor, divide by that number. 12 goes into 12 once. 12 goes into 36 3 times. 28 and 14, you're like, even, all right. Or maybe even 7, or maybe even 14. So you try to reduce by that common factor. Let's assume you didn't see the 7 or the 14. And you start dividing by 2. 2 goes into 14 7 times. 2 goes into 28 14 times. And you still have the 7 and the 14. You're like, oh, they're factors of 7. You keep on reducing by that common factor, and that's leaving you with the simplified numbers. At the end, it's just multiplying 1 times 1, which in this case would be 1, and 2 times 3, which would be 6, giving us a simplified answer of 1/6. So finding the GCF, guys, will save you a lot of time when you're trying to multiply fractions, divide them. Reducing fractions would be useful, guys. Next step, what to do for the LCM, or how is that be applicable, guys? So here, that will help us when we're trying to add or subtract fractions. That will come in handy when we apply the rule of finding the LCM. All right, guys, sorry about that. We left off on the point of how would it be useful when you're trying to add or subtract fractions. And let's put both examples. Let's assume we have 5/8 added to 3/5 added to, what do you want? 1/2, guys. So in here, we cannot add or subtract fractions until the numbers on the bottom have the same denominator. In order to do that, we need to find the LCM. So again, in case we forgot, we could write the 3 numbers, which is 8, 5, and 2. And we could do the little upside down division chart. 2 goes into 2 once, 2 goes into 8 4 times, but it does not go into 5. Oh well, just bring it down. And keep on asking yourself the same question. Does 4, 5, and 1 have anything in common? If they don't, you end up multiplying everything on the bottom times everything on the right side. So here, 5 times 2 is 10. 10 times 4 would be 40. What does that mean? That 40 would be our LCM between the relationship of 8, 5, and 2. 8 goes into 40, 5 goes into 40, and 2 goes into 40 as well. What do we do with that number? We're going to change equivalent fractions. What are we doing to the 8 to make it a 40? We're multiplying it by 5. So that factor, we multiply it times whatever we had as our numerator. 5 times 5 would be 25. Do the same thing with the other fraction. How many times will 5 go into 40? 8. 8 times 3, that would give us 24. And last one, what are we doing to the 2 to make it a 40? It goes into 40 20 times, and 20 times 1, that will give us 20. Now, all of your fractions have the same denominator. It's just a matter of adding our numerators to get a final result. So what's 25 plus 24? That would be 49 plus 20. That would be 69 over 40. So that would give us the answer. And that's pretty much an answer, but it looks kind of weird, guys, because the numerator is larger than the denominator. So you want to do a little division on the side. How many times will 40 go into 69? For sure, once. That leaves us with the remainder of 29. How do we write this answer? One whole number left over, or remainder, 29, out of the same denominator we had. So our final answer would be written as 129 over 40x, guys. I hope this video helped. Please be on the lookout for more videos down the road, and stay safe and take care, guys. Bye, guys.